let's get started. This is building web-based analysis and simulation platforms with React, Flask, Celery, Bokeh, and Numpy. We're at PyData London 2017. It is Friday, May 5th, 2017. I'm James Powell. It's my pleasure to be here presenting this tutorial for you. I don't have any prepared material for this. This entire tutorial is live coded. I hope that you will join me in live coding this. Now, before I get started, I have just a couple of comments I'd like to share with you just to contextualize this tutorial. So you may have seen me checking tickets earlier today and just thought that was what I do. But no, I'm actually a volunteer for NumFocus, and I do quite a few things related to NumFocus and PyData. But unfortunately, whenever I come to these conferences, and I come to a lot of these conferences, there's always this one question of, James, what do you actually do for work? And I'm so tired of that I thought for once in my life I'll actually give a talk about what it is that I do for money. So this is very much unlike any of the talks I've ever given before in that it's useful and work-related and something that you might actually be asked to do for somebody and get paid money to do it, as opposed to the usually completely frivolous stuff I like to talk about. There are a couple of problems with this tutorial. When I showed some of this to Ian and Calvin, they said, that's impossible to give. You'll never be able to give this tutorial. It's not going to work. And they're probably right. That said, a lot of this tutorial is live coded, and you're encouraged to follow along. There are a couple of things that will cause you to struggle, and I have one or two small solutions to help you out with that. What's going to cause you to struggle is, if you're a slow typer, we're going to go very quickly because we only have 90 minutes. And there's not much we can do about that. If you have difficulty with window management, you're going to have a tough time because to actually make this work, we need to have 5 long-running processes running simultaneously, and it's just going to get really messy because you're going to have a lot of tabs open in your terminal. So I'm sorry, there's not a whole lot we can do. I hope you have a really nice tab terminal or you use Screen or Tmux. The nature of these technologies is that they have lots and lots and lots of moving parts. Now, to help you out, you can see there's a bit.ly link right here. And you should go to that bit.ly link. And what you'll see is an empty Dropbox directory. This Dropbox directory is where I will be doing all of my work. So at certain points in this tutorial, when you may realize that you have gotten behind on some part, you can just go into here and download exactly the code that I have. It's already populated with a couple of pieces that are necessary in order to make this tutorial work. I have tried to minimize the number of pieces that you won't be able to write for yourself. Let me give you a little bit of the context for this talk.
Sorry, could you show us that first?
So it's this link right here.
Yeah.
And then if you go to that link, then you'll see the Dropbox. So what I would suggest is keep a clean web browser instance open with Dropbox open, and then later on when we actually build our framework, use that same one. If you get confused with the other tabs that you have already open, you're going to have a bad time. Also, open up a terminal, and if you can create tabs in a terminal, create a couple right now. If you use Tmux, jump into a Tmux session. If you use Screen, jump into a Screen session. Because I'll try to minimize the amount of jumping around, but I simply can't. If you do not have Anaconda installed, I would make sure that you have Anaconda installed as soon as you can. It is not necessary to have Anaconda to use these technologies. However, I have designed this tutorial such that you do not need anything but Anaconda to get it to work. So we'll actually install Redis, Celery, Node, and a couple other things all through Conda and a couple other things through pip. So as long as you have Anaconda installed in your system, you should be OK. If you don't, then it's going to be kind of tricky. You'll have to use whatever your native package manager is on Homebrew or Ports or apt or whatever that is. If you're on Windows, you might have difficulty getting some of these dependencies simply because I don't know for certain that Redis will run on Windows. And unfortunately, the second half of this tutorial is extraordinarily fiddly. So let me give you the premise for this tutorial. A lot of what I actually do is what would not be classed as data science work. When I was at, last year at PyCon, there was a discussion in the core developers room about some of the type work that Guido has been working on. This is PEP 484, I believe. And one point that I brought up to Guido was that some of this type hinting stuff really isn't that relevant to data scientists, because you can't really add meaningful type hints onto data frames or ND arrays, and that's what you need. Most code that a data scientist writes is take in a data frame, pop out a data frame, and the mechanisms by which they expose structure, the typing mechanisms by which they expose structure, don't really accommodate any real checking of that. That discussion evolved, and a very interesting point was brought up by Guido, which is essentially he sees that there are two types of people in the world who use Python. There are the people who are paid for the code that they write, and there are people who are paid for something that they write code to do. Most of you who are data scientists aren't paid for the code that you write. Your task is to optimize some business process or to decide whether to buy or to sell something, and in pursuit of that, you write some code. This is not what I'm paid for. I am almost always paid for either advice on how code should be written or code itself. My deliverable, whenever I actually work, is code itself. And so most of the projects I work on are what you might call, the kind of corporate terminology is digitalization projects. An older terminology that we still use sometimes is what you might call Excel remediation. The idea is some analyst somewhere has written some analysis with some black box model, and it needs to be put into production. It's not enough that it runs on their computer in an IPython notebook. It actually needs to be part of some production system. And the key to that production system is often some kind of web presence. In the case of these, it's often an analysis platform where you have a core set of analysts who know how to design and tweak models, and you have some analysts who only know how to use models. These are business analysts, not data scientists or data analysts. And so they need to have some interface by which they can use that model that's suitable to what they know. And what they know is not Jupyter or Python or any of that. More broadly, you can imagine as a data scientist, your ability to deploy or to send your code to other people is oftentimes limited to what you can actually stick into a Jupyter notebook. And Jupyter notebook, just IPyMB files are just a very poor way to distribute anything but fairly simplistic narrative analyses. If you have supplementary libraries, then you either have to direct them to pip install something, or you have to do some weirdness with sending them a zip file containing a requirements.txt and an IPyMB file. If you have data files, you have to zip those up and email them to somebody as well. If you have parts of that code that you cannot share, you're stuck. For some of my projects, we have simulation platforms, physical simulation platforms, where certain constant factors in the equations which we're optimizing over have been discovered as a result of very painstaking industry analysis. They are proprietary. Nobody on the project is actually allowed to see the constant factors that are used in the equations. We are given dummy constant factors that we use for prototyping the system, and then at some point when we hand it over to the client then goes in and actually fills in those constant values, because there's literally 10 scalar values that they can't share with us because they're worth more money than the entire team put together. And it's just because for this particular proprietary business process, for these particular proprietary business processes, this is knowledge which they can't share. And so you simply could not distribute these analyses as a Jupyter notebook, because how could you hide that proprietary information? That said, beyond that motivation, I'm just going to assume that all of you have some interest in seeing what you can build using these technologies, and I won't push that any further. However, it is necessary for me to mention a little bit of motivation, because when we get into the second half of this tutorial, you're going to see that the technologies that we're using are very fiddly, and they are not nearly as easy to use as some of the technologies we'll use in the first half of this tutorial. Namely, almost everything in the JavaScript ecosystem is going to be, I don't want to prejudice you because you've already been prejudiced against JavaScript by reading web blogs, by hearing from your friends, by following people on Twitter. You're already prejudiced to think things like the JavaScript ecosystem moves too fast. Nothing is stable. There are no 10-year libraries. You write something today, and by tomorrow it's out of date. I won't say whether these are true or false. What I will say is it's clear that there are many more moving pieces that are necessary to be effective in that ecosystem. And what I will say is, for most of you who are paid not for code that you write, but for analysis that you do, even though you may need to build these systems as part of a requirement that is either imposed upon you or something that you want to do, you probably don't want to read any documentation. I have about 30 seconds time span of attention before I get tired of reading documentation. I am exceptionally lazy, and I'm not very smart either. And so I can only read through about 30 seconds of documentation before I get bored. which is why when I started getting into these technologies as part of work I had to do, I struggled. Because in order to pick up one of these things, you have to read through and invest a lot into a set of build tools, a set of an execution environment, a set of languages, frameworks, components, and it just is a lot to think about. So one important caveat for this tutorial. I would not call myself a React, a Flask, a Celery, a Bokeh, or maybe half of a Numpy expert. But I'm not a React, Flask, Celery, or Bokeh expert by any measure. This tutorial is designed for somebody who is not a React, Flask, Celery, or Bokeh expert and who doesn't want to be, who wants to use just the bare minimum of these tools to accomplish a task, but understands that at each step of the way, you're going to be making compromises, you're going to be incurring technical debt, you're going to be doing things in a more expedient but a informal or sloppy way, and that at some point in the medium to far future, when you say I need to address that technical debt, or when I do something a little bit more sophisticated than what we see in this tutorial, you will then invest the time to learn that. Frankly, the problem I see is a lot of these technologies take too much upfront investment. So what I'm going to try and present to you is the absolute bare minimum upfront investment to actually get something to work. And in order to do that, I'm going to compromise significantly on the quality of the work that we do. I'm also going to compromise on the maximum possible sophistication of the example that we have. The example that we have and the use of these tools will not be sophisticated. So if you are already a React, Flask, Celery, Bokeh, or Numpy expert, there's almost nothing in here on any one of those topics that will be interesting to you. What is interesting in this tutorial is the combination of those. So without further ado, let's get started. And I'll give you the motivating example that we're going to work on in this tutorial. So many of us, when we were in school, we took a probability class. And in that probability class, we learned a little bit about Monte Carlo simulation. And so the motivating example I wanted for this, and you'll see why I chose Monte Carlo simulation, is some simulation that takes time, that's slightly more complicated than maybe a linear regression, and and has memory and processor requirements, in that it's not something that you can immediately do inline. You actually have to go off and create a job server. And so just to review the core concepts, I'm going to pull in a couple of libraries from Numpy. So I'll just pull in square root and linspace. And you don't have to follow along in this part. I'm just giving the motivation. And I'll tell you when you should start following along. Although don't think that since you don't have to follow along from the beginning, that means you can goof off for the rest. So here we go. We have square root and linspace and uniform from NumPy. And so the quintessential example of Monte Carlo simulation is estimating the value of pi. And the way that you do that is you draw a unit square, and you have a fourth of a circle, and you drop random values on that, and you count what's the ratio of values inside the circle versus the ratio of values outside. So in NumPy, it would look something like this. Let's create a linear space from 0 to 1 with 1,000 samples. Let's create ys, which is the square of these. And so this will actually represent what our unit circle looks like. So here's our x and y values for our unit circle. What I'll do is I'll import bokeh plotting.figure, import figure, and IO from bokeh. And I'll actually plot this for you. And so this is your very simple bokeh tutorial. We'll create our figure, and we'll show our figure. And there's one actual thing we have to do in addition to this. We also have to grab an output notebook. And instead of something like your magic command, your matplotlib notebook, in Bokeh, you just do output notebook as a function. And it sets you up to do Bokeh output in that notebook. So here, once I run this cell, you can see I have an empty plot. Let me hide some things so you can see as much of this as possible. I have an empty plot. In this plot, I'll just do a line plot with my x's and my y values, and I'll make it blue. OK, so what you can see is we're just going to drop pins on this and count the ratio of the ones inside and outside. So what does that look like? Well, let's decide the size of the simulation we'll do. So we'll have 1,000 points. And we'll just create some random variables drawn from uniform distribution, drawn from 0 to 1, where the size is this size and 2 points each, is x, y coordinates. So there we have our random points. And then to calculate how many are inside, we just take the x coordinates and square them. and we add that to the y coordinates squared, and we compare that against the radius. So now we can add into this diagram. We'll grab the x coordinates, the ones that are inside. And again, you don't have to follow along too closely. This is just a motivating example. So those are the things that we dropped inside. And if we look at the ones that we dropped outside, we'll see the essence of this simulation approach. And we'll just negate this to get the ones outside and make them red. And there you can see the ratio of these values gives us an approximation for pi. So our pi approximation would be the sum of the number that are inside divided by the size. And since this is a fourth of a circle, we multiply times 4. This gives us pi over 4, the ratio of these. The ratio of the area of the inside the circle to the entire unit square. And so let's pull in one more thing from IPython. And now I'm just showing off here. Display, import LaTeX, display. We got to show off a little bit because you're going to be really disappointed at the end of this tutorial. Display LaTeX, and then we'll just do so we'll do some fancy LaTeX because we're going to approximately format pi raw equals true. Whoops. Oh, we gotta, sorry. This should be display LaTeX. Thank you. So so there we go. So our approximation is 3.088, and if we run this, we'll see. And what we can see, if we increase the number of samples, is it gets very slow, and our approximation does not converge very well. This is a pretty poor way to approximate pi, because you can see with this many samples for how slow this is, it doesn't do a great job. In general, this is not a particularly good approximation approach. You can see with this much data, we only get 2 decimal points. But you can imagine that this is now, from this point, kind of a black box. And from this black box, we'll just imagine we have some model, and that model is slow. And we can't run that model every time somebody does an endpoint request. We have to find some way to run it in a job and determine what status that job is in, if it's pending or whatnot. And so we'll see those pieces kind of inch together. But this is the core of what we're going to do. Now, what we want to do to make this more interesting is we'll generalize it. What we'll try and do is we'll generalize the problem of computing the area under a curve, computing an integral. And so in our application, we will take an arbitrary equation in terms of xs, the x values, and we will take the extents on the x-axis, and just for hinting, the extents on the y-axis, and we'll actually approximate the area under that curve using a Monte Carlo method. And that's our black box model. The reason we choose this black box model is a couple of things. One, there's a visualization component of seeing the dots and using the dots to kind of drive some understanding of why the approximation might be good or bad. It takes a lot of time to run these simulations. It may take 1 or 2 seconds. So there's certain considerations for that. And 3, we need to be able to customize it. We need to do something more than just running a single black box with set inputs. We want to think, can we do something a little bit fancier, like allow the user to specify what the algorithm is? That's the motivation. So with that, I will save this notebook, and we will not see this notebook ever again. So we'll save that. Now, one thing is, if you are on the Dropbox, you should be running live, but you should see everything is getting saved. Well, you can download them, but everything is getting saved live. OK? What you should do next is the following. In the folder where you're working on this tutorial, create 2 folders. Actually, create 1 folder. Call that folder backend. We're going to work on the backend side of this. We're going to take this algorithm. We're going to write a Python script to implement this algorithm. From that Python script, we're going to wrap that in a REST API that takes JSON data as input and returns JSON data as output. From that API, we're going to take the algorithm, and we're going to spit it off to a job server using Celery. That should take us about, hopefully, 30 minutes. Once we have that, we'll build the web front end using React as a single-page app. Hopefully, we can get through the next 30 minutes. We have about 20 lines of code to write. But actually, they're not even that hard for 20 lines of code. So let's get started. I have a brand new Anaconda environment, which I'm using for this tutorial. Now you can see here's my notebook running in my TMUX session here. Ooh, it got really dark in the room when we switched from. Check that out. Look at that.
For using Python 2 or 3?
I try and use Python 3 because I don't know how much of this will work in Python 2 versus 3. I don't think there's anything where it should matter if you're using Python 2, but you'll have very slight differences, and getting as close to my environments as possible will make it easier for you. OK, so we're going to start by just writing the algorithm out for computing exactly this. Now, in this backend folder, I want to show you a couple of things that you can ignore in this Dropbox folder. Ignore this file env. I'm going to use this in this example. I don't like Conda environments, and I don't like virtual environments, so I wrote my own version of them. You don't want to use it. I use it because I think it's better, but nobody else agrees with me. So just ignore this file env. It's just for my own setup. And ignore when I use it. Just make sure that you have everything installed. You have your Anaconda on your path and whatnot. You can ignore the IPyNB checkpoints, of course. You can ignore the Git repository. I won't be committing these to Git as I go, just because I don't think we have enough time to do it at that pace. Focus just on the backend and the front-end folders. Don't download the front-end folder first, because it has a bunch of junk in it that we need to talk about before we can look at it. So just create an empty folder for backend. In this folder, we will be writing 3 Python files. And we're going to start with the very first one. And for the very first one, we don't actually need anything interesting installed, because we're just going to write raw Python code. And so this is going to be called algorithm.py. And one thing that I'll do is you should be able to see at the bottom of my screen right here. If you're ever curious what file we're in, just check the bottom of my screen right here, and I'll tell you what file we're in. We're in Dropbox tutorial algorithm.py. So we're actually in the wrong place, because we need to be in the backend folder. That's mistake number 2. I wonder how many, we can take bets on how far we'll get by the end of 75 minutes. According to Calvin, this will crash and burn in the next 5 minutes. So let's prove him wrong. I would really encourage you to try and code along at this point. Everything that we'll be doing, I'll try and go slowly enough. If you miss any steps, just save your work off to the side, and you can grab it from the backend folder. I'll make sure that my code works. But part of this tutorial is to tell you this. I gave you 5 technologies. Some of you in this room, I wish I had time to survey where all of you are, but I'm sure some of you in this room have never used 4 out of those 5. Hopefully everyone's used Numpy, but there's a chance that some of you have never used the other 4. And what I'd like to tell you is, even though they're not easy technologies and they have a lot of depth, there is a shortcut path through becoming effective at building something that can do what is close enough to a real-world problem without having to learn that much. And you'll get a lot more out of struggling with following along than if you just passively turn on the TV, sit back, and watch the show. OK. We're gonna do something very simple. So we'll say from NumPy import lint space. We need a linear space because actually we don't need a linear. Yeah, we do. And we'll also grab from numpy.random. We'll grab uniform. And the reason we'll use uniform is that it gives us the low and the high values. NumPy.random gives you something on a uniform interval of 0 to 1. But you can think that if we're going to be able to set the integration bounds, then we're going to want to be able to have a nicer interface for saying, give me a random value between -2 and 2, without having to multiply and subtract. We'll create a function called approximate, and it'll take 5 arguments. F, the function, A and B, which are the integration bounds. So you'll be integrating from A to B. We'll take hints C and D, which are the bounds on the y-axis. When we generate random values, remember, in the case of our pi simulation, we were dealing with a unit square. Here, we're dealing with a sketch. We're dealing with a unit square, so it didn't really matter what we did. But here, we're going to want to be able to integrate over. Oh, this is really slow to start up. Bokeh takes a while to actually repopulate the graphs. This is one thing that Matplotlib is a little bit better at. I'll let you know when that's ready. But we were dealing with a unit square, so we didn't have to care about. We were just generating random numbers on that interval of 0 to 1 on the x and 0 to 1 on the y. Here, since we want to be able to integrate anything arbitrarily, we want to be able to know as a hint. We have to know what the x values are, but we need to know as a hint what the y values are, just so that we don't start generating random values that definitely would never be in any relationship to where the function is. We want to make sure that we generate a good portion of them beneath the function and then take the ratio of the areas. Now, one thing that makes this kind of tricky is that we're going to take this function as a string. So we're going to allow the user to input a string, and they're going to use the variable x's for what the, I don't know, is that the endogenous variable, the exogenous, whatever the x-axis, for the x variable. And in order to do that, we can use the built-in Python eval, but you can think we're already, that's kind of ugly because then somebody could misuse our system. As a very slightly, barely safer way to do this, in simpy.parsing.simpy parser, they have a eval expression. So that'll make sure that at least you can't pass arbitrary Python code here. You can only pass what a simpy expression can include, which is basically all the arithmetic operators plus some function calls. Now, to make that work, we need one more piece. We need to import NumPy, and this piece is a little bit fiddly. So what I would suggest is you might just want to go to Dropbox and get it. Import eval expression needs to take a dictionary for the local variables and the global variables. It cannot take a module. So in order to give it access to everything in NumPy, I'll just give it a simple this. And so what I would say is this line is a little bit tricky to, this line here, 8 and 9, is a little bit tricky. So if you want to do, you can go to Dropbox, go to backend, refresh, click on algorithm.py, and just cut and paste these 2 lines. That might not be a bad idea if you find that you don't want to rewrite that from scratch. It's only a very small thing around the use of eval expression. And then we'll make this quite easy. We'll generate uniform random we'll generate random numbers on the interval from A to B uniformly of the size that was specified. We'll generate y variables from C to D of the size that was specified. And then we'll just compute how many are underneath the curve, because we're trying to integrate under the curve. And so all that requires is that we say the ys values that are underneath eval of the expression f with my locals, or I can make this, I'll just do this like this. This is maybe a little bit easier for you. And our NumPy dict. And what this will allow us to do is this is one single line of code that will allow us to pass a function as a string and to evaluate the function using the x values that we have and to compute what's under the curve and what's not. And then, simply enough, we just return the sum of what's under, that's the count of things that are under, divided by the size times the area of this box. And the area of this box is simply the d minus c extent times the b minus a extent, just the height times the width. And that's it. That's our Monte Carlo approximation for the area integral. Now, there is a better approach for this. There is another formulation of this that is better than what I have here, but it'll make it a little bit harder for us to generate that little dot diagram. So we'll go with this worse approximation so we can get the pretty pictures later on. Now that we have this, we'll make this a Python script. And this is where most of your analyses will probably start. They'll start in an IPython notebook, and then you'll want to actually make them available for people to use. So you'll turn it into a Python script. And we'll grab f, a, b, c, and d from argv. We'll say size is equal to int of argv6 if it's provided. We'll allow you to do the size optionally. Or you can just presume that they have to take it. Don't worry. Otherwise, we'll assume a size of 100. And then we'll just do a little bit of conversion, because these are taken in a string. So we'll just say that's map int a, b, c, d, like that. OK? So we'll just make sure those are all ints. And we can swap the order. Doesn't matter. Then we'll just say print integrating blah, blah, blah from blah, blah, blah to blah, blah, blah with blah, blah, blah samples, f, a, b in the size. And we'll say the approximation is equal to, we'll approx, which is f, a, b, c, d, and size. One script that does the core of our analysis. Now, one thing that you'll find is as part of a business process, if you were to take the amount of time and the amount of money that's spent actually building a business, often a minority of it spent on the model itself and a majority of it spent on hiring a lot of people to put it into production. And so what you'll see is this is basically all of the data science in this talk, about 5 lines of code. And the rest of it is actually putting it into production. It's my experience that oftentimes when you look at the size of organizations, the number of people who are data scientists versus data engineers, the amount of money that's spent putting something into production versus doing the initial analysis, and the amount of time that's spent doing the initial analysis versus putting it into production, it matches kind of the same. You have 5 lines of code of real meaty NumPy, and then lots of infrastructure pieces. So we're basically done with the NumPy part. Now, having done that, I'm going to split my pane, and I'll make it so that you can see that. And I'm just going to run this. So I'll go into my backend directory, and I'll just say Python 3 algorithm. And of course, ignore the env. That's just what I do to get my environment. And I'll pass square root of 4 minus x squared as my function. I'll integrate from 0 to 2. I'll give it hints of 0 and 2, and I'll let it work. And of course, I have to call it xs. There we go. So its approximation for pi is 3.08 with 100 samples. And if I run this again, with 1,000 samples, 3.12. If I run it again, one nice thing you'll see is the notebook is remarkably slow at creating very large NumPy ND arrays. It actually was much faster in raw code, because you can see if I did this in the notebook, it actually is slower, even if you ignore the time that it takes to do the graph. Now, I don't know if I can actually do ND array with 10 million samples. Look, with 10 million samples, the best I get is 3.1423. Let me do that one more time. Let's just time it. Let's see how bad this is not a very good approximation, because you can see it's slow, it converges very slowly, and the best I'm getting for my approximation of pi is 2 decimal points after 99% CPU usage in 10 seconds. But many of our black box, that's another thing that I see in production, really bad models. So you can, instead of taking this as a criticism of the Monte Carlo approach for this particular problem, just take this as one more piece of the real world, which is sometimes what you're putting in production isn't a very good model to start with. But you still have to put it into production because it's what you got. Is everybody ready to move on? Or do you need a second or two? If you need a second or two, I'll give you, say, 3 minutes. And in those 3 minutes, anybody who has any questions can ask them, and everybody else can tune out and just copy. If you don't want to copy along, you can always just cut and paste from Dropbox. It's not such a big deal. I'm going to get this whole thing on the screen. This is all of the algorithm code that we have. That's it. We'll actually revisit this file one more time to add in the Bokeh piece later. Any questions? Most of you start. I mean, if you really think about the process, you start in a notebook, you sketch something out, then some engineer comes along and puts it into a Python script. What's the next thing? Well, putting it into a Python script doesn't really help that much, because at some point you need to expose this to the web. And we know one argument that we had over lunch was whether you're really buying into something when you choose REST and JSON as your RPC mechanism. And I made the incorrect assumption that one of the things that you have to buy into in this talk, one of the things you have to agree is a right way to do things, to say that you have to buy into REST and JSON APIs is to say that you have to buy into breathing air and drinking water, that it's such a fundamental and ubiquitous part of our lives that it really doesn't involve that much buy-in. I would revise that and say maybe the next part of this, the approach that we're going to have, is more like buying into eating cereal for breakfast. You go to the store, you go to Tesco's, you go to the aisle for breakfast food, and there's cereal there. It's just a choice that a lot of people do. There are many better ways to structure this. There are many different RPC mechanisms. You may have your own opinion of them, but JSON, REST, that's one of the most common things that people ask you to do. So let's do that next part. And in order to do that next part, we need to use one of our first actual non-data science libraries, Flask. It turns out if you're using Anaconda, Flask is already installed. You don't have to install anything at this point. If you are not using Anaconda, you're going to have to figure out how to install Flask. Ideally, pip install Flask, and you're done. Good luck. For me, I'm using Anaconda here, so it's already installed. So I'm going to create another file. And this other file is going to be called restapi.py. And in restapi.py, I'm going to just write a little Flask app that will serve an API, will serve these results over some HTTP API. So again, I'll make this a Python 3 script. And one reason that we can use Flask for this, so one nice thing about Flask is One thing I didn't want to do in this tutorial, or I wanted to minimize in this tutorial, is what I see as an unfortunate case in a lot of tutorials, even in the Flask tutorial, especially in tutorials of tools like Django, which is the first 3 sections are, well, why don't you install this and set up your file structure like this and create all these empty files and all these directories. And frankly, you don't care about that. What we're going to do in this tutorial is we're going to write everything in as few files as possible. We're going to take what in a normal project should be 3 files, and we're going to write it in 1 file. Just because we want to get something working quickly. And honestly, done is better than good. Flask is actually a pretty good tool in that what you'll see is our use of Flask is going to be very, very minimal. There's not a whole lot that we have to know, or not a whole lot we have to buy into to make this work. So we'll import Flask from Flask, and we'll create a Flask app. We'll create a name block. And in this main block, this name equals main block, we'll run our app with debug set to true. Our app can't really do much. It can't serve anything to anybody. Now, if I try and run this app, I'll do env Python 3 REST API. You'll see, port's already in use. Maybe I'm running the answer in the background. Because it'll default to port whatever. So just make sure you're not running anything else at the same time. Let's try that one more time. There we go. But our Flask app can't do anything, can't serve anything to anybody. But it's sitting here on my machine at localhost 5000 if I want to access it. Can't do anything very interesting yet. Now we want to actually do something interesting with this. And so what we want to do is we want to be able to, I don't know, like actually run the algorithm. So we'll pull that from our, we'll pull a prox from algorithm, and we'll just create a simple endpoint, app.route. And we'll set it at the root, and we'll just have a function. And it'll be called, for now we'll call it put task, because we'll use that name just to minimize. And we'll just go into the, we need 1 more import from Flask, we need 2 more imports from Flask, request and JSONify. Request gives us access to all the things that were sent as part of the request, namely the JSON body of all the arguments you send. And JSONify allows us to automatically return some results in JSON. So we'll just say A equals request.json of A. B equals the same thing for B. C equals the same thing for C. We're just going to unpack all the arguments that we were passed. In fact, maybe F is the first one that we want. And thankfully, we have access to a fantastic technology called cut and paste. And then once we have that, we'll just say our result is equal to JSONify. Actually, we'll say our response is equal to some result. And we'll call approximate with FABCD. And we'll get the size as well. We'll say request.json.get of size. And if it's not provided, we'll default to 100. There we go. And then we'll just return JSONify of the response. That's it. This is basically the core of our Flask app. Now, we need to add a couple more pieces to this. But before we do that, I want to show you this in action. Now, to show you this in action, you'll need to actually trigger this API. Now, triggering it through your browser is going to be a pain. So here's what I suggest. Using whatever tool you have, ideally Anaconda, do a pip install httpie. This is a tool that is way easier to use for testing JSON APIs than curl. It'll allow you to do something like the following. http get http localhost 5000, and let me pass the parameters. So my parameters would be f is equal to, what was it, square root of 4 minus xs squared. My a, and I'll put a colon here to make sure that it's a interpret. This is an httpie ism to make sure this is sent as a number and not a string. Because remember, JSON does have some rudimentary types. And I'll leave this one on the screen after I run it. Where is this running? We don't have our Flask server running, which is why this doesn't work. Here is where your life is going to become miserable. You need to have a window or a tab or something else open. And in that tab, we're going to open 5 panes running all of the 5 things we need to actually make this stupid task work. And the first one is running our backend server. So here I'll do again env python 3 REST API. Our Flask app is up. Now if we go back to where we're writing the code and we try and query our Flask app, you can see it gave us our result, 0. So let's just make sure we have F, A, B, C. Oh, there we go. That was a typo. And you can see we're now querying this over a REST API. That's basically the core of it. Now what I'm going to do is I'm going to give you a minute or two just to make sure that you're caught up, or to copy from Dropbox. Make sure you have Flask running in the background. We honestly need to have 5 separate services running to make this example work. It's just the nature of how this works. When you actually deploy this to production, there are a lot of tools that you'll have to simplify that, from Docker to systemd. But when we're kind of hacking on something locally, it gets ugly. So hopefully you have some window management solution like tmux or Screen to make this easy. Who needs another minute to get this ready?
What was the name of the
httpie, httpie. Or you can use curl, it's just that curl is ugly. And just so that I can do that, I'll show you, this is what my call using. When you install it, the binary is called, or the executable is called http without the IE. And actually, if you look in the Dropbox, I'm gonna make sure my install notes. If you look in Dropbox, I'll put, if you look in Dropbox in the backend folder, there's a list of all the things we'll install. So this is the one that we installed. We'll install these 5 things before the tutorial's over. There we go. Now the problem here is as follows. 1, the built-in HTTP server, the mechanism by which we're actually serving requests, HTTP requests via Flask, the one that's built in, you don't see anything beyond just this app.run. It's single-threaded, and I don't know if it can service multiple requests simultaneously. When you actually deploy this to production, you'll use some tool like gunicorn or gosh knows what, gevent, or there are many, many choices, and you'll go and you'll research them to actually make this work for large numbers of simultaneous users. One of the problems, even if you do that with large numbers of simultaneous users, is when we bump up that size too high, we're going to block. So whatever worker is servicing the HTTP request is going to just sit there and block. And you have a finite number of workers. And whatever is making that request is going to block and not be able to get anything back. So we need to make this so that we have a job server, so that when you submit something to our system, to our platform, instead of just running it, it creates a job that runs in the background or runs separately. And then we query, is that job ready or not? And if that job's ready, then we pull the results out. So let's see how we do that. In order to do that, we need to install 2 more things. Actually, we need to install, 2 more things. We need to install Celery. We can write our own job server. If next year I'm invited to speak again, maybe I can show you how to write your own job server using tools like using Curio or Async.io. It's not that hard to write your own job server. The thing is, you won't be able to get the same quality of tooling that existing libraries will give you. We don't have time to write our own job server. So instead, we'll use something off the shelf. We'll use Celery as this task manager / job server. And we'll try and write as few lines of Celery as possible. So we won't use any of the sophisticated features in Celery, knowing that potentially certain features of our job server that we need that are very sophisticated may not even fit into Celery, and we might have to write it from scratch eventually. So we're just going to do the simplest thing it takes to get this working. At this point, all of you should have a working Flask app. If you don't have a working Flask app, I would suggest that you save your work off to the side and take a copy of what I have in the backend folder. To turn this into a Celery app is not that hard, but we have to actually install Celery. So in my side window here, I'm actually going to install Celery. And I can pip install Celery itself, But one thing about Celery is, and I'll explain to you in very basic terms what it is. Celery is a separate process to which you can submit tasks. It will run tasks. It will be able to tell you when a task is completed, and it will be able to send you the results of that task. There are two important components for running Celery: the mechanism by which you submit jobs and the mechanism by which you get the results back. The easiest mechanism for submitting jobs is a simple message queue message broker called Redis. We will have to install Redis and run it as a separate process. Thankfully, throughout this entire tutorial, we will never have to restart Redis. We may have to restart our Flask server if we change the routes too much, but we'll never have to reinstall Redis. So you can just get it starting somewhere in the background. If you're on a platform where you can apt-get install Redis or something like that, then don't worry about this. If you're not, and you're going to install it the way I'm going to install it, which is via Anaconda, then you're going to have to manually start it up. And you'll know if you haven't started it correctly. So the first thing that we'll do is we'll pip install Celery using Redis. The second thing that we'll do is we'll conda install Redis. Now, in order to conda install Redis, it's not part of the basic conda libraries. So we'll need to use a line that looks like this. Now, if you don't know where that line is, if you look in the backend folder and install.sh, here are all the installs we're going to do. So we're going to do the one that says Redis next on line 5. And hopefully it's in the background. With all of us jamming on the Wi-Fi at the same time, I might have to switch to my existing environment. It's fetching the package metadata, solving package specific. I'm like the person who sits in the passenger seat of your car and reads the signs as you're driving. It must be incredibly irritating. It's solving package specifications. That must be a lot of package specifications it has to solve. Let's go ahead and install this. Should take about another 30 seconds, and then we have Redis installed.
While we're waiting for this, can you save all the command line commands in the file as well as we go along?
Yes, I can actually. Let me do that here. I'll do it in the here. What I'll do is I'll do this. I'll do hist file equals history shell. And so let me run the. So let me do. So you'll have to read through them because you don't have this env program that I have. But what was it? Env http get http localhost 5000. And it was it's a get request even though we don't want this to be a get request eventually. Square root of 4 minus xs squared. And a was equal to 0, b was equal to 2, c was equal to 0, d was equal to 2, right? And that should give us a result. Let's see. Yep, that gave us a result. If you look in Dropbox, there should now be a file called history. Called history. And it should contain, let me make that history.sh. Because that way you don't have to download it. History.sh. OK. Let's see that. Go back. Thank you. That was a really good idea. So we'll refresh this. History.sh, and you should see that's my Z shell history. So it'll just keep track of all the history in that one terminal. So you'll at least be able to see them even if you can't cut and paste these. Just cut and paste from where you see the word m to the end, assuming your environment is set up correctly. OK, we've got Redis. We've got Celery installed. Let's start up Redis. So I'll create another tab here. And starting Redis is pretty easy. You just do Redis server. And that's basically it. You will never touch this again. Open a terminal, start in the background. Redis won't crash. It doesn't ever need to be restarted. We just need it running. If you apt-get installed it, you'll be fine because it'll be running as part of whatever your init mechanism is, your systemd or your, heaven forbid, xinetd or whatever. Now, we're going to write another Python script. And that Python script is going to be called worker.py. In worker.py, we'll actually use Celery in order to implement these tasks. This is a very simple script. It'll only be 5 lines long. Celery has a very easy learning curve to do simple things. From Celery, we'll import Celery. From algorithm, we'll import approx. We'll create a Celery app. And we don't really care what the name is, but it's called worker. And we have to pass some parameters. The backend is how we get results coming back at us. So we'll just have the results via some RPC mechanism. And the broker is the queuing mechanism by which we send results in. So here's one small thing that you need to be aware of. When my Redis server started, at the very bottom here, it said the server is now ready to accept connections on port 6379. If you install this via brew or apt, you should be running on the same port, but there's always a chance you're not. So there's always a chance that you're not. So just check that line. Hopefully you are. And we'll just set the broker to that. Then we just need to create the Celery tasks, and it's very easy. We can just say integrate equals app.task of approx. Now this is a decorator, but we don't really need to do anything in the decoration. Typically what you'll see is you'll be written like this, app.task def integrate blah, 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 blah. But we can write it a little bit shorter because we don't need to pass any different arguments. So there we are. We have a Celery task that can be launched from a worker. That's it. Actually, let's make this a little bit better because we're going to have bugs in our code later. So we'll actually do it the other way. So we'll say app.task def integrate, some args, some keyword arguments. We don't care what they are. We'll do a try, approx, the args and the quarks. And if there's any exception, we'll return nothing. That'll save us from some things that potentially will crash later. So you could do it that way, or you could do it the easier way. The easier way would just be integrate equals app. If you don't care if it crashes or not, you can do it that way. OK? That's it. That's all we need to know about Celery. Trust me, it gets worse from here. A lot of you are already thinking, oh my goodness, it gets worse. And unfortunately, that's the nature of the technologies. There's really not a whole lot we can do. We are cutting as many corners. We are cutting an enormous number of corners. But it is not unreasonable. I don't think it's unimaginable that somebody in your work environment would come to you and say, OK, we expect this to be deployed in some web-based form. We don't want to hire somebody else to do it. Why don't you figure out how to do it? And you're required to do all of this stuff. And that's the purpose of this tutorial, to at least give you that ability and to show you that it's possible to hack your way through it without completely giving up. Because when we get to the next section of this tutorial, it's going to look pretty hopeless. JavaScript ecosystem is a lot to learn about. OK. I should be. Somebody say something really positive and optimistic. I'm going to go into my backend, and I'm just going to. I'm going to start my Celery server, and it's very simple to start the Celery worker. It's just there's a program called Celery, and we just give it the name of the Python script or the name of the worker, which is called worker. Then we tell it it's starting a worker, so it says worker twice there, and we'll just set up.
Are you sure it's called worker? Because it looked like it was called app.
It's called worker. It's this one right here.
Oh yeah, okay. So it's just the file. It's the file name rather than the thing.
Yeah. So it's the app. It's the app that it's the A here is the app that you're using, and the app happens to also be the module name. Maybe I should have named it something different to avoid that. And I'll just say the log level is a debug log level. There we go. And you can see it can't quite connect to my Redis server. So let me just make sure I didn't do anything wrong here. 6379. 6379. Let's try this one more time. Oh, I misspelled localhost. By the way, I hope you'll all join me for the pub quiz tomorrow, where you will be required to spot small bugs like that in order to impress your colleagues with how well you know Python. Here we go. So we have now 3 components running. In the top left, we have our Flask API. In the top right, we have our Redis queue. And in the bottom, we have our Celery worker. Now, once you have that, does anyone need a second to get up to speed with the Celery piece?
Yeah, can you show the command again?
To start the Celery worker, I'll put it in this one. I'll just put it as comment here. But it is Celery. Actually, put it in the file itself.
Cool.
Run with Celery-a worker log level equals debug. So get that. And I'll say how to start Redis as well. So Redis is just Redis server. So with those two pieces, I'll give you 2 minutes.
I'm getting an error of argv is not defined.
Do you have from sys import argv at the top of your, right here?
Yes.
Double check. And if not, set yours off to the side and cut and paste from me because we're a little bit behind schedule already. We can run a little bit over. Because the next part is so you think this is bad. This is the part that was supposed to be like, wow, it's so easy. Because honestly, the website of this, the tool we'll use here, React, is a whole heck of a lot friendlier than the way we used to do this with Django and Jinja and templates. But it's still, there's a reason why people do this as a full-time job. Maybe at minimum, what you'll get out of this tutorial is some respect for those JavaScript monkeys that we all make fun of. They live hard lives too. We're going to improve our Flask app. So we're going to do a little bit of code churn here. We're going to improve this. And the way we're going to improve this is instead of running this task directly, we're going to start a Celery task that'll run it in the background. And we're going to add a way to query whether we have task starter or not. So what we're going to do is at the top of our script right after this, we'll just create an empty dictionary, and that'll represent all of our running tasks. What this means is every time we restart our Flask server, it has no permanent storage. So all of our tasks and all of our results will die, which is good because we don't really need permanent storage for this example, and because it'll allow us to clean the slate by just restarting our Flask app. So this is a dictionary that will store all the tasks, and I should call it tasks with an S. It'll store all of the tasks that we've started in Celery, all the jobs, as it were. This here is called put task. Really, it should respond not to a HTTP get method, but to an HTTP put method. So I'll say methods equals put to make sure that if you need to actually send something in, you put it. And what that will change is when I'm running my HTTP command here, instead of doing a get request, I'll use the put verb. Otherwise, nothing else has changed. You can see it's the exact same thing. I just used the put verb. The reason I do that is I want to reserve the get verb for something that makes sense to get, i.e. the list of all the running tasks. So I'll say app.route, and I'll route on the index, and I'll say methods equals get, and I'll get all of the tasks. I'll call this a function. I will call this function list tasks. And this function will list all of the tasks that have been submitted. I'll say tasks is equal to task ID, and then whether or not it's ready, task.ready, for task ID task in tasks.items. Little simple thing there. And I'll just JSONify that and return it. There we go. That's it. And here, the only other change I'll make is right here. Instead of calling this function directly, I want to do a delayed evaluation of it. OK? And that's as easy as just saying approx.delay. Instead of the decorator that we used, actually it's called integrate.delay because we changed the name of it. Integrate.delay. And instead of getting approx from the algorithm module, we'll get from worker import integrate. So there we go. Those are the changes. But what you can see fundamentally is instead of having one function that runs eagerly, we have a function that gets scheduled, and the .delay is your way of scheduling this in your Celery worker. That's it. The major changes are here, here, and this piece here. Yes, that's absolutely correct. We need to store the task. Thank you. Let me do it this way then. Task ID equals, thank you, that was a really good observation. Task of task ID equals that. And the result will just be the task ID passed back to us. There we go, thank you. So I'll maximize that. I'll give you a minute or two to either cut and paste from Dropbox. Who's given up completely and is now cutting and pasting every step of the way? It's OK. It's OK. It gets worse from here. Trust me. Oh, it gets. Oh my goodness. JavaScript.
Yeah, there's that comma at the end of line 24.
That's fine. That's there.
For anyone who's copying off the screen.
Yeah, that one you can remove. So if you're going to cut and paste from Dropbox, just wait till I run the code to make sure it works. Might be a good hint. I'm a very imperfect person. I make many mistakes. To err is human. To forgive something. I can't remember that.
Nobody else gets the error from Redis.
If you're returning something from Redis, you get a pickling error from Redis if you're returning the just dictionary, right? Maybe we should start with here's how I install VirtualBox. There you go. There you go. For those of you who are managing to follow along this far, even if you're struggling, I'm extraordinarily proud of all of you. I don't know if that means anything. It shouldn't, but I am. Because I understand how difficult and how much I'm asking of you here.
This is getting grumpy because I've got two things that are doing things.
OK. What I'll do, just to keep this on the screen, is I'll split my window the other way. Did you even know that you could split your screen so many ways? And let me do one thing. Let me do my little hist file equals da-da-da. There we go. And I'm going to show you http get localhost 5000. And this will give me all the current tasks. None. I have no tasks. Of course. Let me put a task. I'll put a task. And I'll say my f equals, give me an f. Maybe we'll just do our square root. 4 minus xs squared. A is 0, b is 2, c is 0, d is 2. We'll put a task. It told us our result ID was 0. We'll see it's ready. It's running in the background. And if you check your little log here, you'll see, hey, Celery got a task and it did something. How about that? Now, the important thing is we want to actually get the stupid result back, right? So we want to get some results out of here. So we need one last endpoint. The last endpoint is the endpoint where we actually get the result back. And it takes one argument, which is an integer. It'll be called task ID. And it responds to the get method, the HTTP verb, the REST verb. And it's just called get task. Takes the task ID. And all it'll do is it'll say response is equal to, and we'll just encode the task ID in there because it might be useful. Oftentimes I find when you're writing these kind of APIs, returning as much information about the request in the response is very helpful because sometimes in the front-end app, there's a loss of correlation between the request that you made and the response that you got. So trying to tell people not just the answer to their question, but the question that they asked ends up saving you from kind of coding yourself into a corner in some places. Does anyone have a friend who, when you're texting them, always responds like 3 texts too late, and you can never tell what they think? Like you'll ask them 3 questions, and they won't respond to them in order? Oh. If only human beings could be as wonderful as computers. We'll say task equal task ID. We'll pull it out of our little tasks data structure. And we'll do this in lieu of something like an actual database or some persistent storage. And we'll say if the task is ready, we'll say the response, we'll just put the result in there. And to get that response is the second part of Celery, the third part of Celery we need. The first was our 5-line Celery app. The second was we get this function with the .delay callable on it that allows you to schedule it. And the last part is the .get call, which allows you to get the result. Now the .get call can take a timeout. Except since we know the task is already ready, we don't need to timeout on it. And then, guess what? We'll return JSONify of our response. Now, thankfully, I'm really surprised our Flask app has never needed to be restarted. Some of you may have to actually restart your Flask app. Now, cross our fingers, if we do a /0, uh-oh, something broke.
It's because it'll have rebooted when we added the endpoint.
So let's see, did it reboot? No, there's a key error. Oh, yeah, so you're right. You're absolutely right. Every time, that's a very good point. What was your name?
Isabel.
Isabel made a fantastic point. One great thing about running Flask with this debug equals true is it does hot loading of code. Every time you change this to the best of its degree, it'll reload everything. So notice we never restarted that app, except it'll reload the module, which means it'll reload our persistent storage. So the reason this failed was no such task existed. We might make this a little bit safer so that if you ask for a task that doesn't exist, you don't get something back. We could do that pretty easily. We'll just be making this I don't really want to do that. So I like my code to be as unsafe as possible. So we'll put our task here. We'll list all of our tasks. It's ready, and let's see if we can get it. How about that? We have now completed a Flask API with a job server that wraps our algorithm. And then the next part of this tutorial is how do we actually make a front-end website that uses this. When you are actually doing this in production, hopefully you'll have more than 90 minutes to do it. Trust me, it's doable in 90 minutes, although to actually prep all these pieces together took more than 90 minutes to do. It may not look like I spent any time putting this together, but trust me, it took a little bit of time to get these pieces together. At this point, if you haven't been able to follow along and you've given up, I know who you are. I can see you having put your laptops down. Go to that backend folder, download the backend folder as a zip, unzip it, and just start up those 3 tasks: the Flask server, Redis, and your Celery server, and you can continue on with the next part of this assignment. Because you'll have exactly what I have, there'll be no problem. Yeah, I'll do the Bokeh stuff as supplementary, because we're running low on time. So do we have a talk after this? No. So what we'll do is we'll do just the simple thing, and in the last part, it's only about 15 minutes. If you want to stay a little bit later, I'll show you how to add in the Bokeh stuff where you actually have the response pop up that beautiful little, here's the dots. Okay? So we'll cut that corner for time. So those of you who've given up, don't give up. Don't give up yet. Give up in like 3 minutes once you learn about JavaScript. Okay.
How did you start the Flask thing?
The Flask app, I'm going to put that in the REST API. I'll show you how to do it. It's very simple. This one, you just start with just Python 3 and then the name of the script, restapi.py. That's it.
What was the command to request to put a task on the queue?
And I'll put these 3. Let me put these 3 lines. Actually, if you look at history.sh, you'll see that's my history of all my things. So it's in Dropbox as well. So
Which subfolder?
it's in the top level. Everything on this little side panel will be in the top level. There. Y'all having fun? OK. Here's the thing. I got in trouble earlier today by saying something that I will repeat that is maybe unnecessarily provocative. But I have given a lot of talks at PyData events. This is my 24th PyData appearance. No, maybe 22nd. I'll count. I'll tell you tomorrow. And I mean this as gently and as lovingly as possible, but data scientists do not care about code. They just don't. They care about their analysis. They care about their research. They care about the immediate business tasks they're trying to solve. And code is just one of the things that they need to do to make it happen, which is why the moment you meet a data scientist who has somehow convinced somebody to pay them money to just work on models, to just write, do all their work on pen and paper, and maybe only use a computer to code things in LaTeX so they can publish it for people, they're happy as can be because you don't care about code. Now, the PyData audience is a little bit different. You're a little bit more caring about engineering. But I have to say I have read the code written not by anyone in this room. I'm sure you're all brilliant, capable, technologists, but by many of your colleagues. And I'll say, if you care about code, well, I don't know. I've read your code. I can't tell. That's OK, because the economics of the way in which we work is not really set up for you to care that much about that code. There's only so many things you can care about in the world. And what you're going to care about is your main skill. Everything else is going to be secondary to that. That's just the way it is. There's nothing wrong with that. When we look at JavaScript in about 30 seconds from now, it's going to be overwhelming, because in order to actually be effective in JavaScript, there is a lot that you have to care about. It is just, it's terrible. There's a reason why JavaScript programmers make as much money as data scientists, because there are a lot of things they have to worry about. What we're going to try and do, to the best of our ability, is eliminate as much of that as we can. But there are certain things we simply cannot eliminate. I bet a bunch of you have written JavaScript, back when I first wrote JavaScript. And what did you do to write JavaScript? Well, you're on your Windows 95 computer, and you opened up notepad.ext, and you wrote alert, hi, hello world, and you wrote an index.html, and you put that little code in there, and you refreshed your browser, and a little alert window popped up, and you were very proud of yourself. Maybe, if you're a little younger than I am, you started with something like jQuery. This is simply not the way in which modern JavaScript single-page apps are written. These days, and I'm not an expert, so if somebody wants to give a lightning talk tomorrow and say why I'm wrong, I would be more than happy to be shown to be wrong, because this is only the impression that I've gotten as a data engineer dipping his toe into this area as a matter of having to actually be paid to do work in this area. The way that JavaScript is developed these days is akin to how we develop in C++ or Java. You write some code, then you have a tool chain that converts the source code that you write to what actually runs. In the case of what we're going to look at here, the tool chain uses a very popular tool called Babel. We are not going to write JavaScript that will run in your browser. In fact, all of the code that we write will not run in your browser. It will have to be transpiled from a JavaScript standard that not every browser supports. We're going to be using the 2016 standard. ECMA 6, I believe, is the formal name, plus some stage 0 requirements that I don't think we'll use, but we'll include anyway. So plus some features that not everybody even thinks will get into the standard at all, plus a technology specific to React called JSX that will allow us to expose one of the nice things about the React technology, which is this component-driven design. We need a tool chain. And so when you were writing C++ and Java in school, you learned, oh, I just type GCC, and it produces an executable. And then when you went to work, they said, well, you can't actually do that. You have to have a make file. And then somebody said, well, you know what? Make doesn't really work that well for Java. Let's have an Ant and Maven. The exact same thing exists in the JavaScript community, except the tools are not as old as the tools we have in the C++ community or the Java community. And it's not clear that they will even exist for the next 5 or 10 years. That said, even though none of this stuff will exist for the next 5 or 10 years, doesn't make a difference as to what you need to do now when somebody asks you today to write the code we're about to write. I'm going to try and minimize the number of things we have to learn in the remaining 20 minutes or so that we have. In order to do that, you'll all have to cut and paste at this point. There is no choice, because there's simply too much. So I'm going to show you what you're going to cut and paste. You don't actually have to cut and paste per se. There is a folder in the Dropbox called frontend. In this folder, I have the most minimal set of things that we need to actually make our single-page app. When you go into GitHub, and if you search for React template, you'll see 1,000,001 React templates. Everybody has one. The problem with those React templates are just like all the Python, Django, and Flask templates I see, which is they give you a template that does 50 things, of which 49 you don't care about. Seriously, the only things we care about right now are building our code to run in a browser and having it automatically build every time we change the file so that we don't have to do something in a side window. We don't have to trigger the compile directly. Everything else we don't care about. Continuous integration, don't care about. Linting, we don't care about. Testing, we don't care about. And the unfortunate thing about a lot of JavaScript tutorials and templates and how-tos that you see is they're going to force you to buy into everything, and that ecosystem has not coalesced around any one specific combination of tools yet. So each one will require that you buy into a different set of tools. The tools we're going to use here are not the best tools. We'll be using NPM. we'll be using Grunt, we'll be using Babel. There may be alternative tools in each case. What I'm going to do is I'm going to use each of these badly enough and quickly enough that when it comes to the point where you say Grunt sucks, or rather Gulp sucks, I'd rather use something else, you can swap it out and you haven't lost that much time. I'll show you what files we have here. Static is our actual, what we're going to serve, the actual static. So this is the HTML you used to write many years ago, except it's been written for you. We will never touch this file. This file contains a basically empty HTML document, and our React code will actually load the app into that. We do not ever have to modify this file. This file, there's a CSS, a style.css, that contains a single directive just to make sure that our code pops underneath the page header. We'll never change this for this entire assignment. The index.html also includes a couple of JavaScript requirements and CSS requirements to make the Bokeh part work and to make basic styling with a CSS framework called Bootstrap work. Even at something as simple as CSS frameworks, there are new choices appearing every single day. I choose Bootstrap because I can show you an example quickly with Bootstrap, and you don't have to know that Bootstrap exists. But it's maybe not the best tool for all uses. But we'll get a lot further making these bad choices than if we get paralyzed by having no choices. Source is where we're going to put the JavaScript source. I have tried to extract some of the components that we need to write to a file called components.js because they're just not very interesting for the purposes of this example. The rest of these files I'll explain to you. Package.json. Package.json is your JavaScript npm equivalent of requirements.txt. We did a conda install and a pip install. If we need to do the same thing to make this work, we'd have to install all these libraries. JavaScript does not come with a rich standard library, and there's no, as far as I can tell, there's no equivalent distribution of JavaScript or distribution of npm like there is Anaconda. Anaconda gave us Flask without us having to install it. It's not really the equivalent here. So these are all the dependencies we need. Just grab that file. This gulp file. This is not a very good gulp file. But what the gulp file will do is it will build our code for us every time we change the file. So we don't have to trigger the compile step manually. It'll save us a little bit of tabbing back and forth. And then finally, this Babel RC. Now usually, we don't have to look at what's inside it, but it gives us the rules for how we take the code that we write, which is not in browser runnable JavaScript. It'll be in a language called ES6 plus JSX, and actually manages transpile. So download this directory, unzip it somewhere, and we're going to go. Once you have that unzipped, the very first thing you need to do, we'll go into my front-end directory now, is we need to install npm. Oh, I should not have closed that tab. That's teacher. So we need to install all our Node modules. But in order to install Node, to actually get the dependencies, to run this code, in order to run npm, we need to install Node. And so if you look at backend install.sh, maybe this wasn't the best place to put it, we're going to install this dependency next. We're actually going to install two dependencies. We'll do this Node.js dependency, and we're going to do this Flask cores dependency. And we're going to do it, we'll have to talk about, actually, we'll just do this one first, because I'll talk about what that Flask cores is. That's a really stupid little, why do we have to do this? So we'll install Node.js. And so the Conda Forge includes the ability to install Node.js. This is an old version of Node. The current version of Node is 7.10. This is 6.10. So I think it's at least a year and a half old. When this actually makes a difference to you, I expect you to go out and figure out how to install Node by some other means. For the purposes of this exercise, worse is better. Done is better than not. So
break anything if I have npm installed already?
No, it'll install it into your Conda environment.
Okay.
So that's the other nice thing about this tutorial. Everything is in your Conda environment. So install this. If you do not install npm, you cannot continue with this part if you don't have npm installed. OK, so this is installed. This doesn't take that long to install. And then we're going to see the great thing. So JavaScript has no, when I do corporate training for people who write code in Java or C#, and I try and teach them Python, I tell them, Python comes batteries included. There's a really rich standard library. And these days, the Java standard library is not bad. And C# standard library is not bad. JavaScript standard library is very, very thin. It is exceptionally thin. And so when we do our next step, which is npm install, we're going to install all the parts that'll make up our own personal Java standard library. And there's a lot of stuff that's going to install. Not just the stuff in that package.json, but an enormous number of dependencies for all of these. So do an npm install, and that'll give you a running node environment.
While
There we
we're
go.
doing that, so those tasks that were launched, what should be their status?
They should be ready. They should be ready.
I'm getting ready false, but
Oh, so your tasks are just, so there might be a bug in your algorithm code where it's crashed or it's, especially if you're running on Windows, I don't know if numpy.random.uniform, I mean, it could be just taking a long time to generate the,
in the logs, 0 seconds to turn.
they should be ready. Okay, so here's all, look at this. This is how much stuff actually, I'll show you. This is disk use, human summary of node modules. So we had to install 80 megabytes of standard library code, all JavaScript to even do the simple hello world we're about to do. Don't let me discourage you about React. It's a really good technology. You think you're having a hard time. The next part is going to be tricky. We need to create a React app. And I'm going to build this up for you, but we're going to go very quickly. What we're going to do is first, in the frontend directory, in the src directory, we're going to create a file called index.js. Okay? I'm going to add the first line. You're going to see that if you have any familiarity with any language that's algol derived, like C, C++, even Python kind of counts, React syntax, more or less, you can kind of read it. Whether you can write React, whether you can read JavaScript syntax, whether you can write JavaScript syntax or ESX syntax, can be a little bit harder because in some ways, modern JavaScript is better than Python. It has some syntax structures that are really nice, that I really wish we had in Python. But in other ways, it is significantly less regular than Python. In Python, if syntax works in one scenario, it'll work in all equivalent scenarios. In JavaScript, you can write this, and when you have syntax that looks kind of similar to this, you can do different sets of things. Don't ask me, well, I can tell you why, but don't ask me why. Next, we're going to import render from React DOM. And then we're going to add just a simple part here. We'll render, and we'll render an h1 that says hello world. And we'll do a document.get element by ID. Now, what you might want to do is you might want to have my code open on the side while we go, because this part's going to move pretty quickly. Now, with that, what you'll see is in my front-end directory, I now have in my source directory, I now have,
Does it try to synchronize all the 8 megs?
yes, it will. It'll try and synchronize all 80 megs. So let's hope Bloomberg has fast Wi-Fi. Let's check to see how slow that's going. Let me see if I can turn that off.
While we're doing that, could you show the index.js code?
There we go.
Awesome.
So let's do general, bandwidth, proxies, account, selective sync, tutorial, front end. No, we want the front end, but we want source and static, but not node modules. Thank you. No, we don't. I don't want to do that because I don't want it to accidentally delete stuff from my machine. So give it a second. It'll, yes, it will, in fact, sync all 80 megs. 80 megs isn't that much anymore. Oh, trust me. Yeah, you remember the days when HTML apps were, 30 kilobytes of HTML was a lot. Even React apps are, prepare for, just be happy that we have caching. That's all I'm saying. OK. Give this a second to somebody watch it and let me know when the index.js shows up. Here's the core idea of React. The core idea, and I'm going to do one thing off to the side. And this is the second to last service you have to start. In the front end directory, And this one's a little bit tricky to start. So in the, let's do this, hist file equals.
Just to check, the index.js should have been in the source folder, right?
Yes, that's correct.
Is there?
Damn.
Oh, see, that wasn't so bad. Thank you, Bloomberg. OK, in the front-end directory, in the node modules directory, there's a .bin. We're going to have to use a file in that, gulp. And we're going to just say gulp watch. What gulp does is it's going to be building our source code. You see how huge that is? I don't know why it comes up so big. Every time I build the code, it'll pop that up and it'll tell me it built. So my React app just built and I can serve it, which means I need to serve it. Now I already have a Flask server serving my API. I need a front-end server to serve my front-end code. I have included this for you. It's very badly written. And it's called http server.py. Just run it as a Python script. Just do Python HTTP server. It will run an HTTP server on port 8000 that serves just the static components. When you actually deploy this, you'll probably use something like Nginx, and you'll have Nginx dispatch for the API endpoints to something like gunicorn, and then directly serve the static content, i.e. the HTML, the JavaScript, and the CSS. So once we do that, now I can go to localhost 8000, and we can see, oh, and by the way, this should be HTTP server, and just put static. So this thing lets you tell it what directory to serve. So we'll serve the static directory. So we'll do this one more time. Hello world, that's our React app. So we can see this is being generated by React. Now that we have this, we can start iterating very quickly. React works along what you might call a component model. So what we'll do is we'll build components representing the different parts of our program. I have a component that I've created for you called layout. So we'll import that and a component called navbar from components. And I'll replace this rendering with layout, where our main is equal to a component called main. What you can see here is what's called JSX. JSX is the ability to transpile in a JavaScript file something that looks like XML. And so what we have is these JSX tags surrounding things which are components. This is a layout component that we can write. This layout component takes things which look like attributes called main, but in the React terminology, they're not attributes, they are properties. And it has another property called navbar, which takes a navbar element that I'm going to create, and it renders. Now what's going to be a problem is I haven't defined main. So I'll show you how to define main. I can define main as just a function that returns a HTML tag. So there we go. It built. It'll say can't load. And we'll see what the error is. I misspelled something.
They're not from components.
No, it should be from .components because it's in the same directory, right? That's a good question because I see why it shouldn't be. Let's see which of these is failing. So this is. Give me 1 second. This part. Is it? Am I looking at this in the wrong place? No, it should be in .components. Yeah. So we'll do this with. We'll just do the layout by itself. This is. Yeah, that's really interesting. What did I do wrong here? I hope the components I gave you. I didn't give you the old version of this. Ah, poop. I gave you the old version. OK.
Oh, that would explain why.
Yeah, there's one line missing. So just grab that file again. That line's missing. OK. Now with that built, oh, and this also has a line missing here too. You're going to have to grab that again because this one had some fixes. So just grab component. Don't try and fix it. Just grab components.js again. In fact, you might want to just start. I haven't done anything that interesting so far. OK, so here's our layout. And then let's do main equals main. Navbar equals navbar. And this is basically the simplest layout that I could come up with. Oh, there we go. We got our Hello World app. And now it looks kind of like a real app. Now we're going to churn through a little bit of stuff. Our main needs to actually have a form that lets you put in those fields. So I'm going to do this very quickly, and it wouldn't be such a bad idea if you cut and paste from where I go. This is a function that returns an element. You can write React components as functions or as full classes. I'm going to write this as a class because I need some additional functionality. JavaScript now has proper object orientation. It still uses a prototype model, but you can do things like extend components. React is based around what you call a lifecycle. So it has specially named methods like render, component did mount, component will unmount to indicate where this component is in the lifecycle. Essentially, React tries to make your life easier by keeping everything stateless. State flows from the top level component down. Components have properties and some internal state that they manage. When they are created, when they're mounted onto the document, onto the DOM, you have the ability to hook into that. When they're rendered, you have the ability to hook into that and update what they look like when they're rendered. So when this thing renders, it's going to do something very simple. I'm going to cut and paste a little bit of this. It will return just that. And here I'm going to do a little bit of churning. Hello, world. Like that. So now with that, you'll see nothing interesting happened. Now, what I'll do is I want to have a React class that represents my pending job. And I want to have one that represents my completed job. OK? And I want to keep track of what my pending and completed jobs are for this instance. So just like a Python function has an init, a React component or a Python class has an init, a React or a JavaScript class has a constructor. I'll call the super constructor, and I'll set the state. So this React component has some internal state. Now, one thing that was originally going to be in this tutorial, when it was a 3-hour tutorial, was a technology called Redux. And the technology Redux and MobX are things which you'll almost certainly want to reach for the moment this app becomes more than 10 components large, when it becomes like 500 lines of large. These are mechanisms for managing your state, for managing global state better between components. You will not see the motivation for it until the app gets large enough, and it won't get large enough in this example. In the render step, I now render all the information I have for this component. So what I'll do is, you can see this is kind of nice, this unpacking syntax we have in JavaScript. I'll pull out the results in the pending jobs, and I'll just do a little bit of magic. I'll call this my, whoops, change the tag, integrator. And I'll have some form here. So I'll just put up a little placeholder for the form. And then I'll show you all the pending jobs. So I'll map pending. This one is a little hard to build up because we're running out of time. Do you mind staying another 5-10 minutes? OK. So here, I'll map all the pending jobs. This is a JavaScript dictionary. And so JavaScript dictionaries, you can actually map over the values and the keys, unlike Python dictionaries, which map only over the values. So here, you get the value and then the key. And I'll just create a, actually, I won't even care what I take. One thing is JavaScript functions don't enforce their arity. Python functions, if you pass too many arguments, it'll fail. JavaScript functions can actually be passed more arguments than they take, and the rest just get thrown away. So here, I will just create a pending element for each of my pending items, and I'll create a results element for each of my result items. Okay? Now this map function, you might wonder, where does it come from? JavaScript is a semi-functional language. One thing that's missing in JavaScript is that some of this stuff is kind of hidden on the built-in objects. And so there's a tool in JavaScript, a library that I would really encourage you to use that will make your life much easier. It's called Lodash. It gives you the ability to do many of the operations you take for granted in the Python standard library, map, filter, sorted, enumerate. It gives you that back. What you get used to when you're writing Python code using the built-ins, you don't have in JavaScript, but Lodash gives it back to you. There's another similar one called underscore that gives you a lot of these helper functions. Now notice each time that popped up red, React components must always return a single component or element. So every time I'm trying to return multiple things, I have to wrap it in either a div or another element. Now that worked. There you go. There's my integrator and my form. Let me make this a little bit richer.
There's a typo on line 9, so if you actually put results in, it's not going to.
Very good, thank you. So here, this will now take a, when you write a React component as a function, it takes as its first argument the properties that are passed in. I'll pass in a property called ID, and I'll make this component very simple. It'll just be an h2 that has pending and then the ID. And you won't see that because I don't have any pending jobs yet. Now, in order to actually create pending jobs, I need to create a form element. This is something that where the React model kind of breaks down form elements. Because form elements have their own internal state, like what's in the form element, and React manages state top-down from parent containers to child containers, things kind of break. Oftentimes what you have is that a form as a child container on a page needs to affect something over here, and you either have to reach for technology called like MobX or Redux, or ideally, you find a nice library for doing forms. Now, the library that we're going to use for doing forms was picked something out of a hat. One thing when you start playing with React that you're going to realize is there is an enormous ecosystem of React components that you can access. And oftentimes, a job that would take you an afternoon to do or a full day to do, you can just grab a component, use it, and be done in 15 minutes. That'll happen to you all the time. GitHub is littered with React components. Some of them are very good. Some of them aren't very good. You're going to use a React component that you're not going to immediately realize is bad, and you're going to get burnt by it. You cannot avoid this. It will happen. Even ones with really nice GitHub README files and unit tests and continuous integration, some of these React components are just not written very well, and it can be difficult to assess without using them whether they will actually fit into your structure, especially because you will not have the upfront knowledge of the React way of thinking. You're just kind of trying to hack something together, and it's going to happen. So just be prepared that for all the time that you save with what we've done, I mean, we've done an enormous amount of work in a short period of time, you're going to lose some time and some code churn by picking bad components. So let's pick our first bad component. And the bad component we're going to pick, and I'm going to grab this one. I'll speed up a little bit just so that we don't take too much of your time, is called Forms React Components. And what it'll do is it'll allow me to very quickly create HTML forms where I can grab the information from them. So I can remove this placeholder here, and I can replace it with a form. Now, I'll show you what that looks like, because I'm going to cut and paste this from my own notes. There. Essentially, this looks very similar to the HTML that you might be familiar with for creating forms. Actually, let me wrap this in a component. Request equals this dot on submit. We'll bind it like that. And then let me just wrap this in a component. And I'll show you what that component is, but we won't look into it in great depth. So these three components really represent the majority of our app. The form itself, and you can see it's one of these forms that takes some function when you submit it, a bunch of inputs, F, A, B, C, D, and the size, and a button that you press to submit. So now that we do this, we need a on submit button here, and we'll just have it do nothing interesting. Now when we do that, finally, we have there. That's what that looks like. That was about 10 lines of code. Sadly, I wish we could have written it line by line together, but I don't know that we have the time. When we submit a job, the pending jobs will show up beneath, and the completed jobs will show up beneath as well. Notice that this looks like a nice form, and you can see this component we kind of picked out of a hat, but for this many lines of code, we ended up getting something that looked pretty nice. This is a story with React There are a lot of components that will save you a lot of time. They might bite you in the butt later, but overall, you're going to be able to produce things very quickly that will look very professional and will work well, which is why there's some motivation for using this. You'll be able to do a much better job than you could with the old style of Django and Jinja templates, in my opinion at least. The last thing we have to do is we have to wire up this form to actually submit the HTTP request. In Python, we use a library called requests. In JavaScript, there is a similar library called superagent, and we will import request from superagent. We'll also import numeral from numeral. JavaScript's standard library is very weak. It doesn't have good tools for parsing things like numeric input or parsing things like dates. This is why you may see popular libraries like Moment.js and Numeral.js for doing these fundamental tasks. We'll use numeral so that when you give some input, I'll just handle that parsing of that input to a float automatically without having to figure out, is this an int, is this a float? You know, do I handle scientific notation and all that? Unfortunately, that's not as easy to do in JavaScript as you'd like. Who likes JavaScript so far? It's actually pretty good, trust me. So here, this onSubmit is a function that takes our parameters like that. I'll generate a payload to be submitted via our HTTP request. Now, one thing you'll see about one big difference between Python and JavaScript is the curly braces in Python represent a dictionary. In JavaScript, they're actually an object. In Python, the keys of a dictionary can be anything. In JavaScript, the default keys of an object are strings. So this does not mean the variable f and the variable a. It means the string f and the string a. In fact, we can even have a shorthand here where in a JavaScript object, if you don't say what the key maps to, this is an entry where the key is the string f and the value is the value of the variable f. That's kind of nice. It's a nice little shorthand. And I'll copy this 4 times. A, B, C. See, I can't. That's mistake number. What are we up to? 23, higher. And then finally, we'll say if size was provided, payload.size equals numeral size.value. Now, one nice thing about ES6 is normal JavaScript historically was not very forgiving of things like trailing commas. ES6 at least makes it friendlier for us to use. Originally, JavaScript was just not as friendly as here. We're almost done, Ruby, in just 1 or 2 seconds. Save it. Now we'll actually submit the request, and you'll see that this looks very similar to, you know, our Python request library. We do a put on some URL. So I'll give you the URL in a second. We send the payload, and then we establish a callback, and that callback has an error and a result. The callback is just some function to be called once the request succeeds. If it's an error, we just return. Otherwise, and here's the magic of this, and this is the last important part of React, and I'm showing you an incredibly brief introduction to React. I will get the results map and the pending map out of our current state. I want to update that state with some new pending jobs. What I'm going to do is as follows. Res.body is the body of the result of the request. Now, when we saw that, we saw, let's see if I can find http get of 1 env 0. Oh, I need to do a put, don't I? So I'll put that, and I'll get it back. And you can see it gives you this result in this first request. We need to pull that out of the body. So I'll say const result equals body, and that's our ID. And I'll do this. Const timer equals set interval. I'll create a timer with that result ID using the set interval function. And what I'll do is I'll poll my endpoint every second until the result comes back, or every half of a second until the result comes back. And then I'll do, this is the magic of React, this.setState. I will set the state of my component, which will trigger a re-rendering. And I'll do this statelessly, so I'll create a new mapping. The ... is our equivalent of the ***. It's called a splat operator in JavaScript. In Python, it would be the keyword unpacking operator. This syntax exists in Python with *** and Python 3, 5, and above. Why am I telling you about Python? We're using we're JavaScript programmers now. And I'll just add this one element here. Yeah, timer.
James, just as a head up, Bloomberg, unfortunately asked us to start vacating.
OK.
Okay. All right, thank you.
Now notice I have a const name result. I need to rename this. Here's how you rename things in React. OK, let's see, I'm almost done. I want to at least take you to the, and then what I'm going to do is I'm going to do, you know, in the cooking show where they say, where the cook just kind of throws things together to make it so easy, and they pick from the bottom oven where their staff had made it earlier perfectly. That's the last step that we'll do. Here, we have our little app, and we can submit. And when we submit, it should show a little pending there. I'm going to copy from my final React app, just because we're out of time. And I have to make some small changes to this. Give me a second, because some things have changed in our thing. But essentially, all we did was we added in that polling function. And I think this should work. OK, there we go. OK, this is our final one. And let's submit x squared 0002. Let me grab my two other ones here. Give me 1 second just to grab my. OK, because I'll show you some. OK. So if you can hold on 1 second. Oh, and there's one really incredibly, unfortunately annoying thing. If only we had another 30 minutes, I could show you. I could show you last.
What we could do is, if people want an extended overflow, then I believe we have some free space tomorrow that we could possibly use in terms of a little overflow tutorial catch-up, in case that helps everyone.
OK. So we can finish this up tomorrow. So the only pieces that we have missing are just to finish our React app and to actually add in the Bokeh response. Now, I will show you, if you'd like to see what the end result looks like, I'll show you what the end result looks like. So give me a second to just kill these servers here, 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 and there. And I'll show you the final. There's my Redis server. There's my Celery worker. There's my REST API. And there's my that. Let me restart. This is what the final one should look like. And when we submit, it submits a job and it gives you the results. And if we make this a really long one, you'll see it's actually polling every half a second for the task to be complete. This takes a long time to view because we're actually going to restart this because that's too many points for Bokeh to show with the way that I'm doing the plot. So there we go. So you can see it's still polling. It's still giving the result. And 100,000 still alive. If you give it a second, while you're packing up, you'll see it pop up the Bokeh graph. Try that again with something a little bit smaller. 1,000 might be. And so there's that. I hope you enjoyed that. It came up just as we restarted. There we go. There we go. And you can see it's pending for the result.